Take a look at this photo. If you think it's just a ship moored next to a beach, then you're missing something big. And take a look at this building in East London. It may look like a regular, boring old office block, and that's kind of the point. In fact, all these places are part of an unknown infrastructure network that never stops running and keeps everything from your fridge to this video working. As well as keeping your phone connected to the modern world, they could also soon heat your local hospital or run your local pool. That's because they contain the cables, servers and computers that make up the internet, and despite their inconspicuous nature, data centers like these are some of the most innovative engineering to be found today. Maybe you've never thought about it, but every video you watch, every photo you look at, and every article you read all lands onto your device thanks to a vast global infrastructure called the Internet backbone. Among other things, it's made up of over 500,000 miles of undersea cables, hundreds of exchange points, and around 8,000 data centers. This enables the data for this video to be requested anywhere on Earth and sent near the speed of light to your phone, tablet, or laptop. Data centers can be used for general internet traffic or for specific uses, like this one used to host Microsoft Cloud services. It's one of more than 300 that Microsoft runs across 140 countries. Constructing Microsoft data centers is a massive undertaking that can run up to 5 years from conception to launch. It begins with a comprehensive assessment which looks at economic, political, and environmental risks, along with security, insurability, and market demands. Once all that's decided, design and construction follows, which involves permitting, material sourcing, and security measures, all of which engages a diverse workforce. These projects generate 300 to 400 jobs annually, covering electricians, plumbers, carpenters, steelworkers, and more, with millions of work hours devoted to each building. Microsoft also prioritizes reducing greenhouse gas emissions during construction, cutting concrete and steel embodied carbon by 30 to 60% by exploring low-carbon materials. After completing the physical infrastructure, engineering teams integrate essential hardware and software, enabling the Microsoft Cloud to run efficiently. Each of these sites is built around the needs of these. This is where the internet lives. A single rack of these blade servers can store several petabytes of data.
When you look at a data center, you will see rows and rows and rows of these servers. And each server basically runs anywhere from 7 kilowatts up to 48 kilowatts of power consumption. So they're really high performance compute with millions of data bits that come in and out of those servers at a time.
To keep all that happening, they need to be powered, cooled, connected to the outside world, and kept safe. That's no small task for the teams responsible for designing and constructing them. Safety is a critical issue here, because if the internet backbone goes down, then the internet goes down. Like in 2008, when Egypt suffered a near total loss of internet after a submarine cable was cut in the Mediterranean Sea.
We build security around the outer perimeter where we have security guards. The whole building is sectioned off inside with a security station. Then you have to identify yourself, and if you're an employee, you have a badge and you can come through the building.
But the best defense is just not to draw attention, which is why the location and identity of most of this infrastructure isn't on a map or even signposted.
We don't put a big Microsoft billboard out front of the data center. You wouldn't even know it was a Microsoft data center if you drove by.
At the heart of this secure compound are the server rooms themselves. The servers are linked by fiber optic cables, which are in turn linked with other server rooms in the same facility by super high capacity cables to create a core network. Keeping a constant power supply is crucial. For every megawatt a data center is powered by, it has just over 1 megawatt in battery storage and diesel generator backup. In an emergency, centers can run for an average of 48 hours off this backup supply before they need refueling. But aside from the energy used to keep the servers running, a lot of power is needed to keep them cool. Because of the amount of electricity they consume, servers produce a lot of heat, which, if left unchecked, could damage or even destroy the equipment. How that heat is managed is constantly evolving.
In the past, we used just air to cool servers, and just like your desktop, you open up your desktop, there's a fan in it, and there's heat sinks blowing air through everything to keep it cool. The beauty is, once you go to liquid cooling, it's much easier to pipe away that hot fluid. So now you could actually start transmitting that fluid to like district heating or to a pool, the neighborhood pool.
These kind of heat exchangers are already in use. In Finland, work is underway on a heat exchange in the southern town of Espoo. A nearby Microsoft data center will make use of low air temperatures to cool its server racks. As the air warms, it goes through a heat exchanger which is connected to the district heating system. The scheme will help the region reach its ambitious CO2 emission reduction targets. And that's important, because by 2025, data centers will use 20% of the world's electricity. But the need to reduce carbon emissions and cope with ever greater amounts of data is driving rapid innovation. This is Microsoft's Project Natick, located off the Northern Isles in Scotland. And it took the idea of water cooling to a whole new level.
And the whole notion was, well, the ocean is cool, and we would have cooling right there. And so it really worked very well. And in fact, what we also found was that because it was purged with nitrogen and there was no oxygen in the vessel, the reliability of the components was on the order of 8 times more reliable.
But if you think this is a radical idea, future data centers might not look like a data center at all.
We could learn from nature and actually develop data centers that are mutualistically working together with nature. How do we look at this game differently? How do we make the data center disappear? I don't even want to say visually, but make it just one. You don't actually look for a beaver dam in the woods. It's just integrated into it. How does a data center just kind of disappear and is one with what's around it, and it's actually helping create oxygen as opposed to consuming oxygen. It creates water as opposed to consuming water.
This project near Amsterdam is going to be integrated into the local ecosystem. Forests and wetland are going to be planted around the centre, which will boost biodiversity, as well as creating greater storm resilience for the area. So, next time you're on a sunny beach holiday or walking past a beaver dam, you never know, you could be just the other side of some of the most pioneering engineering this planet has ever seen. This video was sponsored by Microsoft. You can learn more about that at the link below. There's also the chance to dive deeper on this and other topics on our channel over on the World's Best Construction Podcast, available now wherever you get your podcasts. And as always, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.